Good morning. So today we are going to talk about the atomic size of ions. Last class, we talked about how to find the atomic size, and we talked about electronegativity. So I'm going to give you a quick little review on atomic size. So if you remember, as we moved from left to right across the periodic table, atoms got smaller. So you can look at the periodic table and say lithium versus beryllium. Well, the further you go to the right, the smaller it gets. So beryllium would be smaller than lithium. As you move down the periodic table, the elements got larger. So if you compared sodium with potassium, the one that's further down the table would be larger. Now, what causes the atoms to get larger as you move down? Well, it was all about the shells. So if you have an atom that has 4 shells and you're comparing it to an atom that only has 2 shells, the atom that has 4 shells is going to be markedly larger. And so that's why. So that comes down to shells. When you move from left to right across the periodic table, it was all about, oh my gosh, it was all about, ladies and gentlemen, the number of protons. So the number of protons determined it. And the more protons you had, the more magnets that we had, which means that the magnets would be able to pull the electrons in a little bit closer. So let's do a couple of examples over here. So it says, which atom is bigger, nitrogen or phosphorus? So here we have nitrogen, and here we have phosphorus. So which atom is bigger? Well, we can just look and follow the trend, because we're looking at trends, and the further down you go, the larger. Why? Because there's more shells. You'll have to be able to explain that to me. So phosphorus has more shells. Phosphorus is on the 3rd shell, or has 3 shells. Nitrogen only has 2 shells. So obviously, phosphorus is going to be a bigger atom. Phosphorus has 3 shells. Nitrogen only has 2 shells. That's the reason for the size difference. Number 2, the question is, which is bigger, sodium or magnesium? So let's take a look. We're comparing sodium and magnesium. Okay. Now, what happens when they're on the same shell? Because both of these have 3 shells. So what are we going to do with the neutral atom? Well, now it comes down to the number of protons. So which element has more protons? So you have sodium and you have magnesium. Sodium has 11 protons, or 11 magnets, right, inside. 11 magnet powers pulling in. Magnesium has 12 protons, or 12 magnets on the inside. And so magnesium is going to be pulling in. So which will be able to pull them in tighter? Well, the magnesium, since it has more protons, will be able to pull in tighter, because it's kind of like magnets pulling against pieces of metal. They're going to pull the electrons in. Remember, this is where the electrons are. So in this case, which is bigger? Well, magnesium is going to pull things in closer, so sodium is bigger. Okay. Now, this question says, which atom is more electronegative, nitrogen or phosphorus? Well, we just talked about nitrogen and phosphorus. So, which is more electronegative? Electronegative means the ability to pull in electrons and hold them. So, we talked last class about if you have something that you really want to keep, you would hold it close to your body, as small as you can. You wouldn't hold something outside. So the further away the electrons are, the harder it is to hold them in. So something that's more electronegative, that can hold onto electrons better, are the smaller atoms. So the smaller the atom, the more electronegative the atom is. So if you can determine which one of these atoms is smaller, then you know the answer to which is more electronegative. So let's look at nitrogen and phosphorus. Remember, nitrogen is on the 2nd shell. So nitrogen has 2 shells. Phosphorus is sitting on the 3rd shell. And which one of these is going to be able to hold those outside electrons closer? Well, nitrogen is much smaller, so nitrogen is going to be able to be more electronegative. So nitrogen is going to be able to hold on to the electrons stronger. So nitrogen is more electronegative. And the same is going to hold here, which is more electronegative. It's kind of like which one is smaller. Whichever atom is smaller is more electronegative because it's holding onto the electrons. So here we're looking at nitrogen and magnesium. So which is going to be smaller? Well, we determined that already. But just to take a look, they both have 3 shells. So sodium has its 3 shells. Magnesium has its 3 shells, but magnesium has 12 protons. Sodium has 11 protons. Magnesium is going to be able to pull the electrons in closer. And so magnesium is going to be more electronegative. So let's look at the trend on this one. As you move across the, oh, I don't like that. Let's do it in yellow. As we move across the periodic table, we get more electronegative. As we move down the periodic table, we get less electronegative because the larger the atom, the less electronegative it is. So the larger the atom, the less electronegative we are. The smaller the atom, the more the atom is going to be able to hold on to those electrons. And that will help determine the electronegativity. So now what we're going to do is we're going to be talking about the size of the particles or the size of the atoms. So this question states, which particle is bigger? Is boron going to be bigger, which is a neutral atom, or is boron's MCI, which is a charged particle? Let's start off by drawing the information with boron. So boron is right over here. And you can see that boron has 5 electrons. So, boron has 5 protons. So let's start this off. So let's draw boron has 5 protons, right? And since it's neutral, right, we're dealing with a neutral atom, and there must be 5 electrons as well. And you can see that we have 2 shells. So we're going to have 2 shells for this boron atom. So let's draw the let's draw the shell model since it's a small atom. So we'll start off. So here we go. So we'll put boron here. There's boron. There's the first shell. All right, here's the second shell. So let's draw on the electrons. So how many electrons do we have? Well, we're going to have 5 electrons total because it's a neutral atom. So there's 1, 2, 3, 4, 5. So there we have our 5 total electrons. And you can see that there's 3 valence electrons. There's 3 electrons on the outside. So this is what boron would look like. Now, to draw the boron's MCI, the MCI, ladies and gentlemen, so boron's MCI, which is also known as its ion, remember an ion is a charged particle, okay? Things are charged like +2, +3, Na+, Cl-. We can determine the most common ion, or the MCI, determining whether or not electrons are gained or lost. So do we gain or lose electrons? And if electrons are gained or lost, that is going to determine what the charge is going to be. So let me draw this one up for you. So the question is, this is boron, and this is the same boron. Don't let the size fool you. I just don't draw very well. But the question to find the MCI, remember that the outside orbital, orbital number 2, can have how many total electrons in that second shell? And you can see that that shell number 2 can have 1, 2, 3, 4, 5, 6, 7, 8 total electrons. Now, how many electrons does boron currently have? boron currently has 3 valence electrons, or 3 electrons in the outside shell. So is boron going to want to gain 5 electrons? 1, 2, 3, 4, 5, right? Or is boron going to want to lose these 3 electrons and then have a full shell on the inside? Now, hopefully, since this is a review, you're sitting there going, you know what? Boron, instead of trying to gain 5, right? Because that's what we have. Instead of gaining 5, you're sitting there going, yep, it wants to do the smaller number. It's going to want to lose those 3 electrons. And so boron is going to lose these 3 electrons on the outside. And this is going to be, all of a sudden, now we have boron, which it has, oh gosh, guys, so sorry. Boron has, ladies and gentlemen, 5 protons, but now how many electrons do we have? We just got rid of 3 electrons. You can see there's only 2 left. There's only 2 electrons left. So what would be the charge on this one? That would make boron have a charge of 3+. And now, once we have this, this leads us to our question, which is going to be bigger, right? Well, boron, neutral, has 2 shells. Boron with a 3+, boron with a 3+ only has 1 shell. So which one is going to be bigger? Well, obviously, boron that has 2 shells will be bigger than boron that has only 1 shell. And you figured that out by saying, well, we know what the neutral atom looks like. Now we want to find out what's the atom look like with its common ion, or it's called MCI. So now we're going to take a look at a couple of examples. Hopefully you have you took a look. And so in order to determine size of atoms or ions, the most common ion is what you'll be using. The first thing you're going to want to be able to do is you're going to take a look at, ladies and gentlemen, sorry about that. You're going to take a look at, number 1, the number of shells. That will always be the first predictor. Next, the number of protons. And lastly, the number of electrons. Now, normally the protons and electrons will be the same, but when they're not the same, that's when they matter. So we're just going to figure out which one is smallest and which one is biggest. We have lithium and lithium's MCI, most common ion. Now, eventually you're going to say, oh yeah, I can figure out what the ion's charge is. So what we have, let's look at lithium. Lithium is in row 1, okay? Lithium has 2 shells. So lithium, its valence electrons would look like this. So lithium has a valence electron. Well, let's draw the shells. I like the shell model on these, and then you guys will grow into the Lewis dot structures. So there's lithium, right? And here's lithium's second shell. And then let's take a look at lithium's MCI. We'll do them both together. Now, I draw these out. I'm not the best drawer in the world, but don't like go, oh, look, that one's bigger, that one's smaller, because my drawings are supposed to be perfectly equal. And if I was amazing, I would probably use Google Draw or something like that, but I'm not. So let's just take a quick look. Now, lithium has 3 protons, and since this one is neutral, the number of protons equals the number of electrons. So that would be 3 protons and 3 electrons. So here we go. 2 electrons on the first shell. And if you're just paying attention, you can see I put 2 electrons on the red line, 2 electrons here, 1 electron on the third, boom. So this is where we're going to leave this here. Now let's take a look and see what's happening. We have 2 shells with lithium with 1 electron on the outside. Now the question is, this is lithium. Now what's lithium's MCI? Well, we have the same number of protons, 3 protons, but since it's the most common ion, we want to try and figure out what will occur. So let's use this one over here to figure it out. Lithium and all atoms want to have 8 electrons if possible on the outside, or 2 for the small ones, because this is considered a full shell. So lithium has the option of either gaining, well, it wants to have 8. So in order to have 8, it only has 1. It would probably have to fill up this whole shell here. It'd have to fill up this whole shell, right? Now to fill up that whole shell, how many electrons would lithium have to pick up? Well, let's look. Lithium would have to pick up 1, 2, 3, 4, 5, 6, 7 more. So lithium can either pick up 7 electrons, or the other option for lithium would be to lose 1 electron. Hopefully, you guys are sitting here going, oh yeah, should just lose 1 electron. And in losing that 1 electron, this disappears. Lithium only has 1 shell, very similar to the example we just did, where we had boron, right? Now we have 3 protons and 2 electrons. The overall charge is going to be a +1. So lithium's MCI, this is going to be Li plus, and this is just going to be Li. Now the question is, which one is bigger? Will the alligator mouth go to the left, or is my alligator mouth going to go to the right? Which one is going to be a bigger atom? This one has 2 shells. This one only has 1. Good. Lithium is going to be a bigger atom or bigger particle because it has 2 shells versus the 1 shell. Now, the next one that we're going to be working with is going to be chlorine. It's going to be a little bit, no, we're not working with chlorine. Let me stop that. Sorry. There we go. That was easy, magic. So, ladies and gentlemen, we're either going to be working with fluorine. So, if we take a look, we want to know which particle is larger, fluorine or fluorine's MCI. So let's take a quick look. So fluorine, I'm going to draw the electron structure to save us time. Again, we're trying to figure out what's bigger, fluorine or fluorine's MCI. We don't even know what the MCI yet is. We have to figure that out. So this is what fluorine looks like. Fluorine is right over here. Oh my gosh. Fluorine, ladies and gentlemen, fluorine has 9 protons and 9 electrons because it's a neutral atom. So this would be the size of fluorine. Now, how many valence electrons does fluorine have? Fluorine has 1, 2, 3, 4, 5, 6, 7. We also knew that because this is the number of valence electrons that fluorine has. All atoms want to have 8 valence electrons. 1, 2, 3, 4, 5, 6, 7. This one has 7, and it wants to have 8 total. So fluorine wants 8 valence electrons. What should fluorine do? Should fluorine gain 1 electron, so then it has 8 on the outside, or should fluorine lose all 7 of those and go all the way down? What do you guys think? Do you think that fluorine should gain 1 electron or lose 8 electrons? No. Do you think fluorine should gain 1 electron or lose 7 electrons? That's right. Fluorine should gain 1 electron. And in gaining that 1 electron, it would become a different atom. I mean, it would become an ion. So fluorine has, oh my gosh, fluorine has, ladies and gentlemen, fluorine has 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Fluorine has 9 protons, so we have 9 protons. But what would be the most common ion? Well, fluorine is going to pick up 1 more electron. And in doing so, fluorine is going to have 10 electrons. So if fluorine has 10 electrons now, what would be the ion's charge? It would be a -1. So fluorine would be an F-. And now the question comes down to which one is bigger and which one is smaller. This one's a little bit tougher, but You can work this out. We have an atom that has 9 protons on the inside and 9 electrons on the inside, which means it's 9 protons, 9 magnets pulling against 9 electrons. And then conversely, you have 9 protons pulling. I'm trying to make these the exact same size, so there's no like, can't cheat. 9 protons against 10 electrons. So do you think these 9 protons are going to pull in these 10 electrons just as well as these 9 protons pull in those 9 electrons? Which one do you think has an advantage? Which one do you think can pull the electrons in closer? Hopefully, you said this one can pull the electrons in closer. Why? Because there's a better ratio. It's 9 to 9 instead of 9 to 10. I mean, just imagine if it was 9 to 20, who would win? Well, the electrons would be pulling a lot further out, right? But that makes this one a larger, this makes the, I really hope I just did that right. I don't even know what I said. My gosh. I'm hoping I just said that that makes the fluoride, the F minus, a larger atom, okay? This compound right here, this is gonna be a larger atom because that's what I asked for, okay? So 9 protons against 10 electrons, this is gonna be bigger because the 10 is gonna be able to pull outwards a little bit easier. All right, let's do a couple more examples and then get you out of here. Okay, I hope I'm keeping you under the time. So let's figure out which is bigger, magnesium or magnesium than Ci. Let's go through it without going through the whole thing. Let's take a look at the valence electrons. Magnesium has 2 valence electrons. So here's magnesium. Magnesium has 2 valence electrons, and it's on the 3rd shell, right? Now, what is magnesium? Is magnesium happy? Well, in order for magnesium to be happy, magnesium needs to gain 6 electrons or lose 6 electrons. And we're going to compare it to this MCI. So what's magnesium going to do? Magnesium is going to lose those 2 electrons, and it's going to go down. Let me count that one again just to get you going. Make those look prettier here. But magnesium on this one is only going to have 2 shells, right? Magnesium is only going to have 2 shells. So what's that going to mean? Well, the one with 2 shells is going to be much smaller, okay? So which is smallest? Well, the one with 2 shells is going to be smallest. So the magnesium MCI, the most common ion, this Mg2 plus charge, is going to be the smaller of the 2 because it's going to lose these last 2 electrons, thus moving on to the 2nd shell. Okay, let's take a look at this oxygen one down here. Oxygen, let's draw the Lewis dot structure for oxygen. So here's oxygen. And oxygen, ladies and gentlemen, has 1, 2, 3, 4. How many valence electrons? Let's see, oxygen's in the 6th column, 6. 1, 2, 3, 4, 5, 6. Now, we're going to compare it to oxygen's MCI, but we don't even know what the MCI is yet. What is the MCI, right? We don't know. So let's find out. Well, oxygen has 6 electrons. How many electrons is oxygen going to want total? Well, oxygen's going to want 8. So oxygen, right here, can either gain 2 electrons, 1, 2, 2 more, or it can lose all of these. And due to our last lectures, whichever is the smaller number, that's what it's going to do. So it's going to gain these 2 electrons. And let me put that in blue for you so that we don't get confused. Hopefully it's the same color. And there it is. That's oxygen's. This would be oxygen's regular one. That's oxygen, which is neutral. And that's going to have 2 shells. But when we move into this oxygen's MCI, right? Let me change the number. Let me change the color. That's going to have 1, 2, 3, 4, 5, 6. It's going to gain 2 more, 7, 8, which means what is going to be the MCI for oxygen? Well, the MCI for oxygen is going to be 2 minus. So that's going to be oxygen 2 minus. Oxygen normally has, this one has 8 protons and 8 electrons, right? 8 protons, 8 electrons, it's neutral. But with an MCI that just gained 2 more electrons, this one's going to have 8 protons and 10 electrons. Now, if something is pulling in and you have 8 protons versus 8 electrons, and it's a tug of war, and then you have 8 protons versus 10 electrons, right? So it's like 8 people pulling against 8 other people. Now it's 8 people pulling against 10 people. Who's going to be able to pull in closer? Well, this one here is going to be smaller. This one, since there's more electrons on the outside, is going to be larger. But this question asks which is smallest. And in this case, it's going to be what? It's going to be the neutral atom is going to be smaller. Ladies and gentlemen, that wraps up my lecture. Hopefully I kept it under 25 minutes. Okay, have yourselves a great day. Thank you very much.